Hello, welcome. Today we'll be solving question number 19 of NEST 2025 exam. The question says four long glass plates with refractive index N1 greater than N2 greater than N3 greater than N4 are stacked in a parallel as shown in the figure. A light ray traveling in the first plate is incident on the second plate at an angle theta that is provided in the figure. This ray pass through the second and the third plates but do not enter the fourth plate. Then the minimum value of theta is. So it says that this ray passes through the first plate, enters to the second plate, then the third plate, and finally do not enter to the fourth plate. That is possible when the ray of light traces the edge of the third plate. Okay, so for that to happen, this angle must be equal to 90 degree. Now we are given that n1 is the refractive index of n1 is greater than n2, then n3, then n4. Okay, n1 has the highest refractive index. So we are moving to high to low refractive index. So for that, if we move from high refractive index to low refractive index, the deviation is away from the normal. So it is like this. The light ray will move somewhat away from the normal like this. And for N3, this light ray will further move away from the normal. Now at last this will finally be equal to 90 degree. That is the case. Okay, this final angle must be equal to 90 degree. That means the first angle, this angle must be greater than theta. As this refractive ray has moved away from the normal, the this angle must be greater than theta. By using the Snell's law, when moving from 1 to 2, we can write this as n1 sine theta 1 is equal to n2 sine theta 2. Now, similarly, moving from 2 to 3, we can write Snell's law as, in moving from 2 to 3, we can write this as n2 sine theta 2 is equal to n3 sine theta 3. How this is possible? Because let's say this is theta, uh, this is theta 1, this initial is theta 1, here it is referring is theta. Now in while moving to the second plate, this angle is theta 2. Okay, similarly by alternate angles, this angle will also be equal to theta 2, and this angle is theta 3 in the third refractive index, third glass plate. uh, this is theta 3. Similarly, by alternate angles, this is also equal to theta 3, and finally, this is 90 degree, the fourth or final thing. So, using Snell's law, now in moving from 3 to 4, while moving from 3 to 4, Snell's law, when we are moving from 3 to 4, it is n3 sine theta 3 is equal to n4 sine theta 4. Okay. So by this, we get to know that n1 sine theta 1 is equal to n2 sine theta 4, as this is, as 1 is equal to 2, 2 is equal to 3, and 3 is equal to 4. So 1 will be eventually equal to 4. So by that, we can write this as n1 sine theta 1 is equal to n4 sine theta 4, and sine theta 4 is equal to 90 degree, sine 90 is equal to 1. So this is n1 sine theta, because theta 1 in the question it is given as theta. So sine theta is equal to n4. This gives theta is equal to sine inverse n4 by n1. That means the minimum angle for the light ray not to enter in prism 4, or not to enter in the slab with refractive index n4, is theta is equal to sine inverse n4 by n1. That is option A. Hence, option A is the correct answer. Thank you. Hope you understood this question.